in lesson 6.2, we're going to look at linear and angular velocity. So hopefully at the end of your homework tomorrow, you can stand with pride and say, I can find linear and angular velocity. Angular displacement, or angle of rotation. First of all, notice it's not angular velocity. Okay? Many of these concepts today are very, very similar, yet they're not the same, and that makes them a little bit confusing. So I'll do the best I can to help you understand the language and understand the physics of what's happening here. Okay? Angular displacement, or angle of rotation, is when an object on a circle moves through an angle relative to its starting position. When it moves through a circle relative to its starting position. So if I look at this, and if I said, there's its starting position, that red line. If I rotate that through a circle and say I stop here, the angular displacement, or the angle of rotation, would say how much of an angle did that move through? Okay? And so in other words, they're asking, what is this angle here? All right? That's what they mean by angle of rotation or angular displacement. Let me pause just a second. Example. Find the angular displacement of 2.75 revolutions round to the nearest tenth. 2.75 revolutions round to the nearest tenth. Say that again for Megan in case she's watching. Question was, where do I start at? The x-axis. And if I put a little ray up here, we could start there. But 1 revolution means that I take this and I go all the way around back to here. And the reality is, I wouldn't have to start there. I could start here if I wanted to. 1 revolution then would take it from here all the way around back to here again. That would be 1 revolution. So how far I go, where I start really doesn't matter. How far I go matters, but where I start doesn't matter. But you're right. We want to get in the habit of always thinking standard position, unless we're told otherwise. Standard position, so the initial side is on the positive x-axis, and the terminal side would be wherever else. So in this question, we're saying find the angular displacement of 2.75 revolutions round to the nearest tenth. And so if I take this line and I rotate it all the way around, that's 1, right? Go around again, that's 2. And 1/4, 2/4, 3/4. So that's where I would end up. And then, Megan, you want to say out loud what you said before?
Take 360 and times it by 275.
Take 360 and times it by 275. Last chapter, that had been a perfect answer. But this chapter, we're dealing with radians, and everything we do from here on out needs to be in radians. In the rest of this lesson, I mean.
And then you convert it.
So I'm not going to convert it. I'm going to do it right now. What is 1 revolution?
It's 2 pi.
1 revolution equals 2 pi. So to change from 2.75 revolutions, I'm going to say 2.75 times 2 pi. Sorry, 2 pi. And they said round to the nearest tenth. And so 2 pi times 2.75 gives me an angular displacement of
17.3.
17.3. Do I have to be in radians to calculate that? No. That is really confusing for many students in your situation when you first start to use radians. You begin to wonder, does my calculator have to be in radians for everything I do? No. The only time it matters is if I'm taking the sine, the cosine, the tangent, the secant, the cosecant, the cotangent. Okay? That's the only time that it matters. Or, like you said, if I'm finding the angle and I'm using the inverse functions of those to calculate the angle. But if I'm using those trig symbols, then I have to be either in degrees or radians, depending on what I expect my angle to be in, or what my angle is in. Okay? But for everything else on the calculator, you're just multiplying. Pi is pi. Doesn't matter if you're in radians, degrees, or gradients. Okay? Pi is pi. Don't ask me what gradients is. I really don't even know. It's on your calculators, and I've never been in a situation where I used it.
Great.
So I really get. It's super radians, gradients. Okay? Any questions on finding angular displacement? Okay, next concept. Angular velocity. I'll pause while you copy this.
We have the prayer.
It's always.
Angular velocity. Angular velocity says the ratio of change in the central angle to the time required for the change. It's a ratio. What do ratios look like?
They have colons in front.
They have colons or
Or, two.
the word to, or
There's a third one.
they can be a fraction, right? Relating these two quantities. The ratio of the change in the central angle to the, time. Underline the wrong thing there. To the time, okay? Ratio of the angle to the time. That angle is going to be the angle of displacement, okay? If an object moves along a circle during a time of t units, then the angular velocity, I think that's omega, I want to say. I'll double check in a second. Omega is given by the formula omega equals theta over t. And theta is that angular displacement, the angle of rotation. Okay? Pause while you copy. Example. What is the angular velocity if 6.2 revolutions is completed in 7 seconds? Okay? So we want to use this formula, and we know that it's 7 seconds. What we don't know is the angle of displacement, or the angular displacement, the angle of rotation, or the angular displacement yet. And so they didn't give me the angle, they gave me how many revolutions. Okay? And so theta is equal to 6.2. What do you think? Louder?
6.2 revolutions. I don't know.
How do we find the angle?
Multiply by 2 pi.
Multiply by 2 pi.
Approximately 39.
So I'm actually going to leave it this, I'm going to actually leave it as 12.4 pi. And then when I divide by 7, I'll get an accurate number that I can then round. Okay, so what do we get if we round that to the 10th?
5.6.
5.6 radians per. That would be my angular velocity. Okay? My angular velocity. And so what that's saying is I'll rotate through my circle. I'm rotating through my circle at a rate of 5.6 radians per second. Okay? Has nothing to do with how fast I'd be running along a line. It all has to do with how fast I'm going through those angles. 5.6 radians per second. Okay? Any questions on that?
Is that a 12 point?
Yeah. My decimal got too close to the tail on my 2. And I'm trying to fix it. 12.4 pi. Dimensional analysis. How many of you have had chemistry before? I think you've done this a lot already. Don't panic on this. Unit labels are treated as mathematical factors and can be divided out, canceled, just like you would the factor of 2 or 3 or 5 or whatever the number was. Okay? So when you are converting, when you are finding angular velocity, your units are going to cancel just like you use it in chemistry. Okay? So that's not new to you. Note, the angular velocity of a point on a rotating object is not dependent upon the distance from the center of the rotating object. It means it doesn't matter how big your wheel is. Whether it's a little pulley wheel on your garage door or it's your 26-inch bicycle wheel. Angular velocity is saying how fast are you going, is that wheel rotating through each of the radian degrees. Each of the radian degrees, that's kinda, yeah. That's bad. Each of your, as it's rotating through the angle, okay? So how fast does it rotate through that angle? So it has nothing to do with how big the diameter of the circle is, or the radius of the circle, okay? If we want to know how fast the linear velocity is, then all we do is take our angular velocity and times it by the radius of the circle. It says if an object moves along a circle of radius of r units, then its linear velocity v is given by the formula v equals r, the radius, times theta, angle displacement, divided by time. So remember, we just determined that theta over time is angular velocity. And it's in radians per unit of time. Has to be in radians. Example. Determine the linear velocity of a point rotating at an angular velocity of 31 pi radians per second at a distance of 15 centimeters from the center of the rotating object, round to the nearest tenth. The formula said linear velocity is equal to radius times theta over t, where theta was the angle of displacement, or the angular displacement, t is the time. But as a whole, this represents the angular velocity, right? And in this example, they told me the angular velocity was 31 pi. And so if you're looking at this saying, well, what's theta and what's t, it's already done for you. It's 31 pi. And so the radius is 15 times 31 pi. So if we round to the 10th, what do we get?
1,460
1,460.8. And then what am I looking for? Centimeters
Per second.
per second, yep. Oops, I tried to write the word centimeter. Make sure you put your units on there. That's the biggest thing I'm seeing from the other class, and I'm not docking them for not putting units on this time, but I will on the next test. You need to make sure you get in the habit of putting units on there. On multiple choice tests, they automatically put the units on for you, but when it's not, you have to do that yourself. So make sure you get in the habit of putting units, appropriate units, on your homework.
Is that it?
What's that?
Is that it?
It is.
My hand is going numb.
Again, remember today you can finish your yesterday's homework, and then you'll have all class time tomorrow to work on 6-2. All right, you've got about 25 minutes